Hey, welcome back to the channel, everybody. This is Kevin, and in this week's video, we're going to take a look at how an attacker might launch an ARP poisoning attack against our network. And by doing that, they might be able to set themselves up as a man in the middle, where traffic going between their victim and the default gateway, where all that traffic goes through them, where they might capture that traffic. And we'll see how to defend ourselves against an ARP poisoning attack. And this video is actually a continuation of a video I posted a couple of weeks ago on DHCP attacks. Back in that video, we configured DHCP snooping. Well, that's actually going to be a prerequisite to how we're going to defend ourselves against an ARP poisoning attack. So if you've not watched that video, I encourage you to go back and do that now. And by the way, this content is coming from our upcoming Certified Ethical Hacker course. And I want to encourage you not to use this knowledge in any unauthorized way. The demos in this video are performed on a local network that I have set up that's isolated from the rest of my network. And if you enjoy this video, please do me a favor, click the like button down below, subscribe, and click the bell notification icon so you'll know when our next video comes out. Now join me as we take a look at how to launch and how to defend against ARP poisoning attacks. In this video, we want to consider an ARP poisoning attack and see how to defend against such an attack. But first, let's review what ARP is all about. ARP, that stands for Address Resolution Protocol, and it's a way for a device on a network to determine the MAC address of a known IP address. Or if that device that we're trying to reach with the known MAC address, if it does not live on our subnet, then we need to find out who our default gateway is. And we'll send out an ARP saying, hey, what's the MAC address for this default gateway's IP address that I have? That's what we have here on screen. The victim's laptop wants to get out to the internet, and right now, in its ARP cache, it does not know the MAC address of 10.1.1.1, which is router R1. R1's ARP cache does not know the MAC address of 10.1.1.100, which is the victim's laptop. And the victim's going to send out an ARP broadcast saying, hey, can somebody tell me the MAC address for 10.1.1.1 that goes to R1? When it goes to R1, R1 suddenly learns that the all C's MAC address is associated with 10.1.1.100. It learned that in the frame it just received in that ARP broadcast. And it's going to respond to the laptop saying, hey, that's me. I've got a MAC address of all A's, we'll pretend. And the victim's laptop will update its ARP cache saying, the MAC address associated with 10.1.1.1 is the all A's MAC address. So now the victim's laptop can reach the internet by sending a frame destined for the default gateway, which has a MAC address of all A's. And when R1 responds back to the victim's laptop, it knows it's sending that frame to a destination MAC address of all C's. But let's imagine that an attacker joins the network. They're going to launch a man-in-the-middle attack. They're able to access an access layer switch maybe in a wiring closet. They plug into an open switch port, and let's say that the attacker has an IP address of 10.1.1.123, and we'll pretend they have a MAC address of all B's. And the attacker is going to try to convince the victim that the MAC address associated with the default gateway is the attacker's MAC address of all B's. So when the victim tries to go out to the internet, it's going to go to an ex-top MAC address of the attacker, not router R1. And because we want bidirectional traffic, the attacker is also going to try to convince R1 that the MAC address associated with 10.1.1.100, the victim's laptop, we want to convince R1 that its MAC address is all B's. Again, the attacker, so we can have that bidirectional communication. So here's what the attacker does. They send out an unsolicited ARP reply, sometimes called a gratuitous ARP, saying, by the way, the MAC address of 10.1.1.1, it's the all B's MAC address. And we're sending that ARP reply to the victim's laptop. And the victim's laptop is going to say, oh, thanks so much. Let me update my ARP cache. I thought it was the all A's MAC address. Let me correct that. I'll update that and say it's the all B's MAC address that gets me to 10.1.1.1. So now when the victim tries to go out to the internet via its default gateway, it's going to be sending frames to the attacker. Now, the attacker also needs to convince the router that the MAC address of the victim's laptop is the all B's MAC address, the attacker's MAC address. So we send out another gratuitous ARP saying the MAC address of 10.1.1.100, the victim's laptop, is all B's. That goes to router R1, and it's going to update its ARP cache. Now, when the victim tries to go out to the internet, its next hop is going to be the attacker, which might then capture the packet and then send the packet on its way so the victim doesn't suspect that anything is going on. And the return traffic is sent through the attacker's computer because we convinced router R1 that the victim's MAC address was the old B's MAC address. So now the attacker has injected themselves as a man in the middle. And there are different utilities that the attacker might be using to carry out such an attack. We're going to go out to a live interface now and demonstrate one called Ettercap. And it's running on Kali Linux. It comes built in with Kali Linux, in fact. And we're going to launch a man-in-the-middle attack. We're going to allow that attacker to sniff some telnet packets going between the laptop and the router. And because telnet is in clear text, we're going to be able to read password information. And then we're going to fix that with a utility called DAI, Dynamic ARP Inspection. So let's hop out now to our live interface. Here on screen, you see a topology where we have a Mac laptop, and that's going to be our victim in this scenario. They're connected into switch SW1. Also connected into that switch on gig 0/2 is an attacker, and they're running Kali Linux on a Mac. Kali Linux is running inside of a virtual machine. So when we see the packets that it's sending out, it might look like it's coming from a source MAC address that is a VMware MAC address because Kali Linux is running as a VM. But let's confirm our MAC addresses are as we think they are. Let's go to router R1. Let's do a show interface gig 0/1. That's what connects into switch SW1. And we can see its MAC address, and that matches what we see in this topology. It ends in 5CE1. Let's check out the MAC address of our Kali Linux machine. Let's open up a terminal, and I'll do an ifconfig. Here's its MAC address. It ends in an FDE1 like we see on screen. And finally, let's take a look at the MAC address of our Mac laptop, which is going to be our victim's laptop. It's got an IP address of 192.168.1.107. If I go to advanced and hardware, we'll be able to see its MAC address. It ends in 14A9. And that matches our topology on screen. So we've confirmed our topology and the MAC address is on that topology. Now let's see the MAC address that the laptop thinks belongs to the router and the MAC address the router thinks belongs to the laptop. And at this point, it should be correct. Let's open up a terminal window on the laptop, and I'm going to do an ARP --A. And it's going to come back with any known IP to MAC address mappings that it knows about. And here it thinks that 192.168.1.1 has a MAC address that ends in 5CE1. If we take a look at our topology, we see that yes, that is correct. That is the MAC address associated with gig 0/1 on router R1. Now let's go over to router R1 and see what it thinks the MAC address is for our laptop, which has an IP address of 192.168.1.107. Let's do a show IP ARP on router R1, and it thinks that 192.168.1.107 has a MAC address that ends in 14A9. And that's correct based on our topology. Now let's see how an attacker might launch a man-in-the-middle attack, specifically an ARP poisoning attack. Let's go back over to Kali Linux. I'll close out our terminal, and I'll use the graphical version of Ettercap. I'll go into the Kali menu. I'll select sniffing and spoofing, and I'll select Ettercap graphical. I need to give the password. I'll accept the default settings. I'm using ETH0. And I'm going to specify the targets of this attack. I'll say targets, select targets, and one target is going to be the router. It's going to have an IP address of 192.168.1.1. The other target is going to be the laptop. It has an IP address of 192.168.1.107. I'll say OK, and I'm ready to launch the attack. Let's click this man-in-the-middle menu. I'll select ARP Poisoning, and I don't want to do a one-way attack. I want to do it both ways. I want bidirectional traffic between the laptop and the router, possibly going out beyond the router. So I'll say OK. And while that's happening, let's open up Wireshark on Kali Linux. Let's select ETH0. And I thought I'd filter for ARP packets. We should see a bunch of incorrect ARP replies coming back. Notice that the source is VMware. That's our Kali Linux machine. And it's sending an ARP reply for 192.168.1.1 and 192.168.1.107. And notice that the MAC address for both of those IP addresses ends in FDE1. Yeah, that's the MAC address of our Kali box. So that's how the attacker launches such an attack. Now let's go over to our laptop and router R1 and see if they're convinced. Let's go to the laptop first, and I'll say ARP -A, remembering that previously the MAC address for 192.168.1.1 ended in 5CE1. Let's see what it comes back as now. And look at that. This time it says the MAC address of 192.168.1.1 is the MAC address ending in FDE1. If you look at our topology, that's our Kali box. Let's go to router R1. Previously, it thought 192.168.1.107 ended in 14A9. What about now? Let's do another show IP ARP. This time, it thinks 192.168.1.107 ends in FDE1. Again, that's the Kali box. So if I go back to our Kali Linux machine and I start another capture, and I want to filter for telnet traffic this time, let's go to our laptop, and I'm going to say telnet to 192.168.1.1. I'm just going to telnet into the router, but this would apply to telnet traffic passing through the router as well. Let's log in. Got a password of Cisco. Let's say enable. Again, the password is Cisco. And let's go back over to Wireshark and see if we can see that information. On Wireshark, I'll stop the capture. Let's select one of these packets. I'll right click and I'll say I want to follow this TCP stream. Now you can see that the router prompt comes up as user access verification. It's prompting me for my password. And look at this. We see my password. Now it's not echoed back on my laptop screen, which would appear in a different color. It would appear as blue if it was echoed back to my screen. But if the laptop is sending it, it shows up as red. So here it is, SISCO. Very clearly, we see that the password is Cisco that was typed in. Then on R1, once I'm logged in, I say enable. Now here we have 2 E's and 2 N's and so on. Again, the red is the character coming from the laptop, and the blue is that character being echoed back on the laptop. It's asking for the password to enter enable mode, and I type in Cisco. Again, it's not echoed back on the laptop, but we see very clearly what the password is. That should be concerning to us, and another reason that we should always use secure protocols when possible. For example, let's use secure shell instead of telnet. Let's use HTTPS instead of HTTP. And let's use FTPS or SFTP instead of just plain FTP. Now let's fix this. Let's go back to our Ettercap screen, and I'll click the stop button. And it's stopping the man-in-the-middle attack. And as part of that, it says it's re-ARPing the victims. So it's allowing the victims to once again know the correct MAC address for the router and for the laptop. Let's go to our switch now and configure this feature called Dynamic ARP Inspection. First, let's confirm that the laptop is convinced of the correct MAC address, and so is the router. So back on the laptop, let me exit out of this, and I'll say ARP space -A. And it thinks the MAC address of 192.168.1.1 ends in 5CE1. Let's check our topology. Yes, indeed, that is the router's MAC address. Let's go back to router R1 and do a show IP ARP. This time, we've gone from the attacker's MAC address ending in FDE1 for 192.168.1.107. This time, 192.168.1.107 says the MAC address ends in 14A9. That's the actual MAC address of our laptop, as you can see on screen. So the victim's laptop and the router, they now see correct MAC addresses. Let's go to our switch and configure Dynamic ARP Inspection. And to configure Dynamic ARP Inspection, as a prerequisite, we have to have DHCP snooping enabled. And we configured that in a prior video, so we're building on that existing configuration of DHCP snooping, and we're going to add the configuration for Dynamic ARP Inspection. The reason it's a prerequisite is that DHCP snooping built a binding table of information it learned by snooping in on those DHCP packets. It knows MAC address and IP address and port number information that was set up through DHCP, and if it sees ARP information coming in that's not consistent with what DHCP said it should be, it's going to create an error. It's going to block traffic on that port. Let's confirm that DHCP snooping is enabled on this switch. I'll say show IP DHCP snooping, and we see that it is enabled for VLAN 1. Let's do show IP DHCP snooping binding, and we can see that a couple of our devices on our network have obtained IP address information via DHCP. And one thing you might notice here is I just renewed the lease on my laptop, and it picked up a different IP address. It's now 192.168.1.108. So let me update my topology. There we go. And let's configure dynamic ARP inspection. Let's go into global configuration mode. And I'm going to trust any messages on gigabit 0/1 because I know where that connects. I know that connects back to router R1. So I'm not going to be examining ARP messages there. I'll say interface gig 0/1, IP ARP inspection trust. And notice I'm setting up my trusted ports before I globally turn on IP ARP inspection, also known as dynamic ARP inspection. The reason I'm doing that is if I don't set up my trusted ports first, I might have a violation on those ports before I get around to saying they're trusted. So I like to say which ports are trusted before globally turning it on. But I'm going to say gig 0/1, it's trusted. Now let's exit to global configuration mode. And I'll say I want to enable IP ARP inspection. Again, that's the same thing as dynamic ARP inspection for VLAN 1. IP ARP inspection on VLAN 1. And I'll do a show IP ARP inspection command. And we see that it is enabled for VLAN 1. We haven't dropped anything yet. We haven't had any violations. Let's create some violations. Let's go back to Kali Linux, run Ettercap again, and see if Ettercap can now convince the laptop to go to the attacker's machine to get to the router, and to convince the router to go to the attacker's machine to get to the laptop. Let's again go under our Ettercap menu, and for targets, I'll say select targets, and I'll use the existing targets we had, except I need to update the IP address on my laptop. It's now 1.108, and I'll say OK. I'm going to launch an ARP poisoning attack. We'll say OK. Now, if I tell Wireshark to monitor what's going on, I'll tell it to watch ARP messages. We can see that this VMware source, that's Kali Linux, it's sending out ARP messages claiming that it is the MAC address for 192.168.1.108 and for 192.168.1.1. We can go ahead and stop that. We've confirmed that those poisoned ARPs are being sent out, but are they being believed? On switch SW1, there are all kinds of alerts going off. Invalid ARPs. We know that the gratuitous ARP information coming in from Kali Linux is not correct. Let's go make sure that it's not being believed by our router. On router R1, I'll do a show IP ARP, 192.168.1.108. It says the MAC address ends in 1489. That's correct. And that's not consistent with what Kali Linux is saying. Kali Linux is saying the MAC address for 192.168.1.108, it's saying that it's itself. Let's go back over to our laptop and see if the gratuitous ARP attack convinced it that to get to the router, we need to go to the attacker's machine first. Let's do an ARP -A. And great news, the laptop does not believe those gratuitous ARPs. In fact, it's not even seeing those gratuitous ARPs because dynamic ARP inspection is blocking them. Our laptop thinks that 192.168.1.1 has a MAC address ending in 5CE1, and it does. It's not going to go to the attacker's machine, believing it's the default gateway. Now let's turn off this attack. Close that out. We'll stop the attack, re-ARP everything, but let's go investigate the switch just a bit. Let's once again do a show IP ARP inspection. Now before, we had not dropped anybody. Now it looks like we have dropped about 47 packets. We've noticed multiple ARP violations. ARP messages coming in on this switch that were not consistent with the IP address and the MAC address and the port information set up by DHCP when those endpoints got their IP address information via DHCP. Our switch snooped in on that. It built this binding table. Again, we'll take a look at that binding table. And those ARP messages coming from Kali were not consistent with this table, so they were dropped. And that's a look at how an attacker might launch an ARP poisoning attack using Ettercap, and how we can defend ourselves against that using dynamic ARP inspection.